Okay, great. Thank you very much, Derek. So today we have Kristi Kline and Kelly Lemig, who are here to present the visualization tool that was just released for Landsat Data in the cloud. And Kristi is our project manager for the Landsat Data Access and Archive project. And she has been with the USGS since 1997, so a couple of years. Started out on the NASA Land Processes DAC, and if you were on this call a couple months ago, we had the LP DAC folks present a tool that they had developed called Appears. So Kristi cut her teeth in the DAC. Since 2001, she's been working on Landsat, and most recently with the Archive and Access project, she's really led the efforts to migrate into the cloud. And so if you're familiar, the Landsat project moved the data archive, so 45 years worth of Landsat data, into the cloud and made that available late last calendar year. And we've been incrementally improving access to that. And so this visualization tool that Kristi and Kelly will speak about today is one more step towards enabling broader access to that full 45-year archive in the cloud. And so with that, I'll probably just hand it over to Kristi, and she can give you a little background about the tool and start the demonstration. And then afterwards, we'll save some time for question and answer as well.
Yep,
okay,
sounds
so
good.
Kristi?
Thanks, Tom.
Yep.
All right, so as Tom mentioned, we just recently moved all of our data into the cloud, and it's a significant amount. I mean, we right now have, around 10 petabytes of data for Landsat, and we just recently reprocessed all of our data, and we did that also in CHS in the cloud. So one of the key reasons we moved to the cloud was so that we could reprocess the data in a more timely fashion. When we reprocessed this last time, we added a lot of improvements to our data, including a whole new product line. So if you know anything about Landsat data, we have been putting out what we call the level 1 product, which is geometrically and radiometrically corrected data. So it's very accurate geometrically, and the radiometry is calibrated. But one of the additional products we've now put out basically takes ancillary information and takes out the effect of the atmosphere, like cirrus clouds and things like that. So we now have a surface reflectance and surface temperature product, and those products are significantly large as well and take a lot of resources to process. So we did all of that in the cloud. The last time we reprocessed about 5 years ago, it took us, 10 months plus to actually process the archive just to that level 1 product. So to go to this new product would have been extremely time consuming on-prem. In the cloud, it took us about a month. So, and that was in a controlled way that we did that processing. We chose how many scenes we wanted to do a day so that we could take advantage of the spot market in the cloud and keep our costs down. So not only did we process significantly faster than we could have on-prem, but it actually was very cost effective. So now that all the data is in the cloud, we want to take advantage of what the users can do with all of that data. And one of the things that we've developed is this LandsatLook tool, which basically takes advantage of that new product, that surface reflectance product in particular. One of the things about that product that is new is the ability to get to the pixel level versus in the past, just the scene level from a Landsat scene. So what I'm going to show you is some of the capability that gets you to that pixel level. Along with putting all the data in the cloud, processing it that way, we have tried to make our products cloud friendly. So we used to put our products out in a GeoTIFF format. One of the things we changed in the cloud was to put out a cloud optimized GeoTIFF. And I could go on and talk about that a lot, but basically what it does is it makes getting to the data in the cloud faster and more efficient by using the cloud resources in a little bit different way. But to the user, you're still looking at a GeoTIFF scene. So it wasn't a huge change from the user perspective, but it really helps us when we're perusing the data through this LandsatLook tool. The other thing we did was we added what we call STAC metadata. STAC is STAC, it's Spatiotemporal Access Catalog. It's basically small JSON files that are set up in a specific way, and we load those into Elasticsearch, and we're able to quickly roll through data in the cloud. And so one of the things you're going to see with this Landsat tool, LandsatLook tool, is in the background using that stack metadata catalog. So what you're seeing right now is the welcome screen. If you don't know anything about LandsatLook, you can come into this About tab, and you're going to see a user guide and some videos that you can look at prior to using the tool. When you're ready to go into the tool, you just hit Explore, and you immediately come into the tool. And then I'm going to just go in here, and well, actually, I'm going to go over here and show you this little button. This is Find My Location. I'm going to tell it to allow that. And in a second here, it's going to find me and zoom in. That's where I'm at, right there in Brandon. EROS, by the way, is right up in here somewhere under this cloud. Okay, so I have zoomed into an area. Now, what you did notice first was you got a map of basically North America, the US. You do have to zoom in before it's going to show you data, and that has to do with refresh limits and things like that. So you can't zoom out to the whole world and see the layer of Landsat data. It's just that would cost us a lot. So you do have to zoom into an area. I can zoom in, further just with a roll of my mouse, and it will automatically update the data here in a second. There you go. Or I can zoom back out. Now, again, as I said before, you're seeing those little blocks as I did that. That's what the cloud optimized geotip is doing for you. Instead of having to go out and pull down an entire scene, it's pulling in small chunks of data that are stored in the object storage in S3. So it basically stores data a little bit differently, but it makes it faster, especially for a tool like LandsatLook. Okay, so some of the other things we can do is, again, this tool is primarily visual, but you do have some menus up here that allow you to change what you're looking at. So right now, I'm looking at this time period, but I'm only looking at Landsat 8 right now, but if I wanted to look at all of Landsat 8, I would go out here and maybe go back to 2013. I'll choose May 1st. And then I'll go all the way to 2020, and I'll choose September 30th, and I'll hit apply. Now it's going to go out here, and you can notice over here, the time bar is going to change, and I'm going to be looking at different data now. Okay, so you can change your date that you're looking at. You can also change the amount of cloud cover. So right now it's filtering everything out that's above 50% cloud cover. And this is a scene-based cloud cover score. And I'll show you some more things about cloud cover in a minute, but I'm going to change it so it sees everything. Okay, now you're going to see that one of the scenes that I didn't have before has a lot of cloud cover in it. So I'm going to just zoom quickly up here because I know there's an area I want to look at. Okay, so we can also change the satellite selection. This is the surface reflectance data that we're looking at, and we've only processed that level 2 product for Landsat 8, Landsat 7, and Landsats 4 and 5. The older satellites, we don't have a thermal band on those. And so doing those products, not only without the thermal band, but also finding ancillary information to remove the atmospheric effects is very difficult. And so we are still working on that, but right now, these are the only data sources you have for satellites. You can also choose tier. When we've reprocessed our data into collections, we created this tiering approach. So real time is basically as fast as we can possibly process the data. We call that real time, but it's not completely calibrated at that point. That comes a little bit later. And then once we have all that calibration information in hand, Then we create what we call a tier 1 or a tier 2 product. A tier 1 product is the most accurate product, but sometimes because of cloud cover or other things, we can't make that product as accurate as we'd like to. And so we drop it into this tier 2 bucket. Some users don't want to look at that, so they might shut that off, and they might shut real time off and hit apply. And then, then you're only going to see those super accurate products, especially, and you saw just now, it removed that really cloudy scene. When you have a scene that has almost complete cloud cover, it's very difficult to geocorrect that image. So a lot of times those data will no longer be in a tier 1 category. Okay, one of the other things you can do at this point is I've down selected data, and now let's say I have all the data I want to share that with somebody. I can go out here and hit share, and it will share that search, and that it'll actually, for someone that you share that with, it'll bring up this exact screen for them. So that's one interesting feature that we've added to this. The other thing I'm going to show you on the menu item is the different bands. Now, in the past, our old version of LandsatLook was just using a browse product. So you only had 3 bands and they were set. In this case, excuse me a second. I can change which bands I'm looking at, and I can do that in a number of ways. The default is a natural color background, but I can also look at a color infrared. And this is going to pull up different bands, and it's all on the fly. I can look at a false color vegetation. And I can look at an urban application color set. And certain things, basically what this is doing is it's using different band combinations to pull out certain features out of the imagery. With the urban one, you can see what pops out here in urban areas. And if I looked at a more urban area than South Dakota, you would see that more so. But you can also choose just a custom band or a single band if you want to look at a single band. The one that is actually most interesting with this newest version of Landsat is a QA band that we've added. And this tells you per pixel what's going on. So for example, in the white is clouds, blue is cloud shadow. If it was a winter scene, you'd see snow and ice. You can see clouds that are cirrus. You can see if there's saturated pixels or occluded pixels. So mostly what you're going to see is cloud and cloud shadow in most of these images. You can also, if you don't like any of those options, you can actually choose your own custom RGB. And this can be interesting, just choosing different band combinations to see what kind of interesting pictures you get. If you've ever looked at any of the, not sure why that one didn't like that one. If you've ever looked at any of the Earth is Art pictures, that's kind of what they do with some of those to get some of the features to pop out is different band combinations. So here in this case, it turned all the water green. That's interesting. So I never know what I'm going to get. All right, I'm going to go back to natural color though for the moment. Okay, so let's see. Oh, some of the other things you can do out here in the bands are do some, we've added this ratios for things like NDVI, for example. So you can get an NDVI out of this. There are several other ratios that you can do as well. Here's the different versions of that. Let's see, we'll go back to natural color. Okay. So another thing is I've shown you over here is a time series. And what that time series is going to do is show you the best image for each month of that year. So when I hit go, it's going to start showing me all of the data that's available for that month. That was part of my selection criteria. You can also export this, which I'll show you how to do in a little bit. But basically, it's going to roll through all of these years over here. And I'm just going to stop that now. So you can kind of see what happens to the data. Okay. So right now I'm going to zoom out a bit. One of the other things you can do is if you want to see how much data is available in your area that you're looking at, you can click on this scenes button, and it's going to show you the outline of scenes. And in the middle is a path row. So Landsat, if you're a Landsat user, has used path row as an identifier for an individual scene. And it's telling me that there's 33 scenes on path row 2929 with my selection criteria. So I know if I were to pull all of this data down that I currently have selected, I'm going to have 33 scenes from this path row, 38 of that path row, 35 of this path row. Okay, so that's one of the other features we've added. Okay. I'm going to zoom into another area here. Oh, that's too far. Okay. What I'm looking for is a scene with a lot of popcorn clouds. Well, I think it's loading. Kelly, any ideas what happened?
Kristi, it looks like it's trying to load because you get data loading, but I don't see anything coming through yet.
Yeah. Oh, there we go. We'll zoom in. We are still working on some things here in the background, so hopefully they're not doing something that's going to cause me issues. Okay. So what you're seeing now is a scene that's got quite a bit of cloud cover in it. Because I've selected 100% cloudy, you know, it's pulling that up. So what I can do, however, is drop this down. And as I said before, with this particular collection of data, we have a lot more information. When I pulled up that QA band, it can tell me every single pixel that is considered cloudy. And one of the things I can do is filter those out. So when I hit this filter pixel and turn that on, it's basically going to go back out and pick out those pixels and replace them with a pixel from a different scene that isn't cloudy. Now it'll pick the closest one in time. That gets really interesting sometimes if I have data that's on the edge of winter and suddenly we went from green or brown to snow. I'll sometimes get snowy pixels thrown in there, but it's you can change that too by changing your dates that you're looking at. So you can see kind of where those clouds had been, and it looks a little funky because there were a lot of clouds in that scene. But now I have a scene with no clouds whatsoever in it. And it's pixel by pixel, the best scene, the best pixel it could find. So that's one of the other things you can do. You can actually also pull up your metadata and download data from here. So if I want to go look for one of those specific scenes, I can download that here. And I'm not logged in right now, so it's not going to let me do that right now. But I can also look at the full metadata of a scene. This is all JSON files that it's pulling, but it gives you the entire metadata stream. And you can see how it's broken up for our particular products. Okay. Let's see. Okay. The other thing you can do is export data. Not just the actual scene, but several things. As I talked before, you can download that time-lapse file and it will give it to you as an AVI file. You can download the entire chunk of metadata that you just queried so that you have that available for later or in some other application. You can download a map view, and I'm going to show that right now. So the map view is basically what I was looking at. I'm going to open it and show it to you guys. So that's basically what I got. So if you needed an image like for a publication, or you just want to put something in a PowerPoint, you can go out here and search for the data and then download that data, and it will give you basically a GIF that you can use. Okay. And then you can also download, and this is new, the metadata search code. So all of this data that I have, if you look down through here, through this search code, right here in particular is the query string that will get you to this, all this data that was in your metadata tab. You know, the May 2013 through September 2020, all of that's in this search code string, and you can drop that right into a Jupyter notebook or into Pangeo and get that same data into your Jupyter notebook. Okay, and then let's see, I think that was my last piece of the tool that I wanted to highlight. Probably the only other thing is over here, you can actually go in and search, like if I want to go to Washington, DC, I can click that and it's going to zoom me into Washington, DC. You can also turn the map labels on and off. Right now, they're not showing up over the top of the imagery. That's one of the things we're looking at changing. Let's see. Kelly, is there anything else that you can think of that I've missed?
And when you're done, Kristi, there's been a couple questions in the chat that I can.
Yep, go ahead, let me know.
Yep, so I've been trying to answer them as we go, but you can maybe expand on further. So the first one was, can anybody access the stack catalog and use it with other tools like Jupyter Notebooks? Yes,
you actually can. So this tool, I think I'd mentioned before, this is a cloud native tool, and it's primarily an open source tool. I mean, it is in CHS, so it's using things like Lambda and Elasticsearch. But in the background, there's a couple of open APIs in particular. There's SAT API, there's something called Stack API, and Dynamic Tiler API. So those are some of the tools that are available to look at the stack data. But yes, it is out there and available, sitting right next to each of the products. The products are also publicly available. You can download Landsat products for free using our machine-to-machine API or this tool, or you can use them directly in the cloud.
So that was great. You addressed the second question, which was, if the data is in a request or pay bucket, which I'd answered yes, but the users can access all the data at no charge through the USGS tools, Earth Explorer, this machine-to-machine, as well as using directly in the cloud within region.
Right. If you're in the US West region, there's no egress costs. There may be some really minor costs for like if you're transferring VPCs or something, but when you're in CHS, there's really no cost for this to egress any data. If you do egress your results or something at the end, then obviously there's egress costs for that. But otherwise, no, once you're in CHS or in region, there's no cost for any kind of distribution.
Yeah. And for the group, I did paste into the chat the link to the USGS website that provides additional access information for all the data access in the cloud, as well as some videos that were produced just to provide, kind of a higher level overview of Landsat data access in the cloud in addition to this LandsatLook tool.
Right. LandsatLook is live right now. We've just loaded it into production, so we're still checking things out and we haven't advertised it yet, but you should be able to get to this. One of the things I did say before is I'm not logged in. You do have to be registered with us to download data. And I'm not logged in right now, but then you would be able to download bands.
And that'd be the same for going through Earth Explorer. You need to sign into your user registration to actually download the data.
Right. And here's where you do that. If you log in here, then it would let me download data.
Okay. So I'm not seeing any other questions on the chat. I don't know if anybody else has any questions they would like to ask.
This is Igor Appel, if you can hear me. 2 questions. There is a presets for bands, some manipulation. Is it possible to manipulate using some very simple request, ratio or something like that? Or it should, formula, what it shows? Okay.
These are all the ratios that we've added. So, you can do a normalized burn ratio, for example, or an NDVI.
Okay, if I want to use my ratio, for example, I need to download bands separately.
You would either download the data to your own system, or you could use like PanGeo to come in and do your ratio in the cloud directly. Or, some sort of Jupyter notebook. So you could do it directly in the cloud as well.
And what about some statistical, like histograms?
Same thing. You could do that directly in the cloud or download the data.
Directly in the cloud, but not in your system.
No, you would have to, I don't, I guess I'm not sure who you work for, Igor.
For myself.
Okay, so yeah, okay, yeah. If you had an Amazon account, then you could come in US West. You could come in and use a Jupyter Notebook, for example. PanGeo is also an open source tool that includes Jupyter Notebook, and that would also be something you could load into your account and use that as well. And it's something that I think we've had other demos of different Jupyter Notebook and PanGeo examples that we've done. And we actually have some on our Landsat page as well as to how to use that.
So it is in Landsat description.
Yes.
Thank you.
Okay. Tom, you had asked what the link is. Is that the link to this tool? Is that what you were looking for? We'll post the link to the LandsatLook tool in the chat here. I think that's what Tom was asking. And the other question was, do we feel these techniques and tools are easily extensible to other data sets? For example, not Landsat satellite or model built.
So this particular tool, again, as I said before, uses a lot of open source capability like SAT API and Dynamic Tiler API. So it would definitely be extensible to anything that's using a stack cog kind of format in the cloud. Obviously, the menus are very Landsat oriented, so that would obviously have to change if somebody was to use this code. But other than that, it's fairly open source. It is dependent on currently being in the Amazon environment because it uses Lambda. But other than that, yes, it could be used for other data sources.
Okay, so Kristi and I both almost concurrently put the link out there for the tool, so everyone should have that. Any other questions from the group? I haven't seen anything else in the chat yet.
Well, maybe just a comment that I think, this is really exciting, and this is the way that USGS should be doing, sort of as Zach alluded, almost everything, using tools that are vetted in the community and sort of eating our own dog food in terms of making, these tools built on the actual apps and everything built using these same systems. And so, I'm really excited to be able to use this myself from the Jupyter notebooks and share it with the rest of the community. And, and we've made use of a lot of the things that are out there in the community. And we're also, I think, like we're, starting to give back as well. So it's kind of like I think this is like an exemplar for how we should work. So, congratulations to you guys. This is awesome.
Yep.
Great.
And Yep, I was going to say we are going to be asking the community for feedback as to, what they'd like to see us add or change about the tool, and then we'll use that feedback. I'd like to have it out there for a little while for people to use, and then we'll use that feedback to plan our next chunk of activities in terms of upgrades and changes.
Thanks, Rich. And any other comments or questions from the group?
Well, is there a place where, say we, develop some nice notebooks, sort of showing how, like Igor, like the question, like addressing sort of the question Igor asked, like how would somebody do something more customized with the data, and somebody creates some cool thing? How do you think we should share that with the rest of the people who might be interested in, working with Landsat data?
Interestingly, Rich, that's one of the things we've actually talked about is, once you've logged in, we've talked about being able to on the fly, like add menus to drop down, like links to your own algorithms and notebooks, for example. If you're a cloud user already, that would be something that might be something we could add to this. But in addition to that, I think there, Kelly, do you know, are there some places where we have shared notebooks or we could link to some shared notebooks? I'm thinking like maybe in our about page, we could add a link out here.
I'm not sure if anybody's on from CHS, but maybe they've been exploring this as well with the data lake. I'm not sure if that's been.
Or GitHub maybe.
Yeah.
Or maybe, I guess maybe we should just like, tweet a link to the notebook wherever we happen to land it, and and say hashtag Landsat2 or something.
Right.
Or whatever.
Yeah.
Right. So we could look at putting something out more that you could see, though. Like I said, I think right now we have a couple of demonstration notebooks out on our website, but maybe we need to make those more visible.
What is the right Twitter handle to use to sort of reference this work?
We have a Landsat Twitter handle.
Kelly, do you know that one?
I'm not sure where it is. Is it just Landsat? USGS Landsat?
Yeah. I'd have to search for that one too.
Yeah, I'm not exactly sure what our Landsat one's called.
That'd be cool though to put down in like the press release or whatever, or whatever it is that's going out with this, to just say, hey, if you do something cool, please, ping us on at whatever it is. Oh, that's
I found it here.
Zach knows the answer.
Yep.
All right, good.
Beat me to pasting it there.
That might be the way to go, right? Just because the notebooks are all over the place, we can't really think that they're going to end up in one place.
Right.
Yeah. Yep.
Yeah.
Cool.
Okay. Anything else? Well, Kristi, thank you very much. I know it's it's kind of the culmination of a lot of work that's been going on over the last year, and it's been very exciting to see the use of Landsat data in the cloud. I mean, since we released it back in December, there's been a lot of use within the community, and so we're excited to see this tool be out there and even further use and visualization of the data. So really excited, and I appreciate you demoing this today, Kristi, and talking a little bit about the activities that have been going on and how we're going to evolve them.
Awesome. Thanks, everybody.
Thank you very much.